Hello everyone, welcome back to our Rhino tutorial. Today we're going to talk about how to model a massage gun inside of Rhino, and let's begin. First, let's click this option and come over to units and make sure that you select the millimeter, and also the absolute tolerance has been set up as 0.01. That's it, okay? And then I will type in picture, which will help me to bring a reference photo into the environment. The next thing I'm going to do is I'm going to draw a line from any point and then hold shift or choose orthogonal, type in 250 and hit enter, which is the size from this point to this point for this massage gun. So I'm going to bring it from here to the start of this line and type in scale, come somewhere here, and then move it to the other end. Hit OK. Then I'll delete this line. I'll type in M from this point, bring it to the origin. The next thing I'm going to do is I'm going to change the color for this default layer into red so I can see the following drawings more clearly. And then I'll lock this image. First, I will draw a curve or line from this point to this point. Okay. And then I will copy it by hold Alt and drag it. I'll click off the orthogonal, type in M, which stands for move it to this point, somewhere here, and then I'll type in rotate. From here to here, rotate it somewhere here. Okay, maybe a little bit more, just to align it better. Make sure that this line will be somehow parallel to this curve. Okay. The next thing I am going to do is I'm going to type in REC, which stands for rectangle, choose 3 points, and start from this point to somewhere here, and then close here. Okay, then I will explode it. Perfect. Then I will make sure that your smart track has been selected. I will draw some lines that's perpendicular to each of those lines. First, I'll come over here, make sure that the midpoint has been selected, and then draw it here, right? You can see this perpendicular line. Then I will draw it here, and then because Smart Track is turned on, I can draw a perpendicular line here to give us this kind of guide. Okay, hit OK. And then I will select this curve, type in move, and move it to here. Then I will extend it, EX, hit enter, select the boundary, hit enter, and then select the curve. Okay. Then I will type in move it from this point, which is mid, to here. Then I will start typing circle, select the 2 points from here to here, again from here to here, and again 2 points to here. Then I will select this curve and rotate it for 90 degrees, and then also this one. Before I rotate it in 3D environment, I will type in rotate and rotate it on 2D. Make sure that those control points will align with this reference line we just drew earlier. And then I'll type in rotate 3D. Select the objects to rotate, hit enter, select the start of the rotation axis, the end, and then I will rotate it for 90 degrees. Perfect. Same thing will apply here. I'll type in rotate first. Make sure that the points will align with the reference line, and then I will type in rotate 3D and rotate it along this axis here. The next thing I am going to do is I am going to go to the top view, select this curve, and type in extrude, or I will just drag this along this direction somewhere here. Okay, when I start to have the curvature, I will stop it right there, and then I will select this curve that I drew earlier, type in extrude curve along curve. Okay, now start to click this path here, so it will go from here to here, go on this direction. And then I will type in TR, which stands for trim, select the cutting objects, which is this line here, hit enter, and then select object to trim, which is this line here. Then same thing, I'll type in extrude curve along curve, select this curve, hit enter, select the path, got it. Okay, perfect. Then I can just select those surfaces, lock them, and then select everything else, send to a trash layer. And then I'll unlock this and I will hide the reference photo. We don't really need it for a little bit. The next thing I will do is I will turn on the steps, and this will tell you what you want to do for the next few steps. And I will explain to you step by step. First, you will blend the curves and make sure that the blend option has been set as tangent. So before that, let's select everything and we will type in extract wireframe. So we got all of those lines, okay? And then I'll type in blend curve, select the first curve, second curve, and make sure that you selected tangency, okay? And I'll hit okay. Same right here, this curve and this curve, hit okay. This curve and this curve, hit okay. Same on the top, this curve and this curve, hit okay. Same here, 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 and here, okay? Perfect. And then I will select all those surfaces. I will click show edge here. And if you cannot find it, okay, it's over here. And then you click this little triangle. You can drag this bar here. We really need many of those tools today. So you better stick it here. And I will click show edges. Okay, they have this option, naked edges and all edges. We will explain that later. But now let's just choose any of one of them. And we see that there's this little knot or this point here. That means the starting point on a certain curve. Okay, so we want multiple of those points. In order to do so, we will click this tool, split edge, and I'll select those surfaces or select those edges to split. I will split from this point to this point, hit okay. And I will hit space, select this curve, this point, and this point, and this point, hit okay. Also, I'll do it on this curve, this point. Again, make sure that you only click this point and this point on this one, the one with the smallest diameter, okay? And then I will start to type in sweep to, I will select the first rail, second rail, and the first cross section and second cross section. See, the reason why we split those curves or those edges is because otherwise we cannot select this segment as our cross section. Okay, I'll turn on the shaded mode and I'll hit enter, hit okay. The next thing I will do is I will type in blend surface. I'll select the first edge, second edge, hit okay. Okay, let's do it again and I'll show you some details. Make sure that you select curvature right here and then you hit okay. Okay, then I'll go to the top and I'll type in TR, which stands for trim. I'll select the cutting objects, hit okay, and then click this off, perfect. Then sweep to again, but before that, do you remember in order to get this section here, we have to have a point here. So I will click split edge, select this edge, click it and get it, okay? And now I'll type in sweep to, I'll select the first rail, second rail, first cross section, and second cross section, hit okay, and I got it. I'll repeat that on this side also, first rail, second rail, first cross section, second cross section, hit okay. Perfect. So we got all of those ones, and let's do the zebra before we do anything else. Let's see the continuity of the surfaces. And right now they are showing on the other side, so I will join them all together and flip it. Okay, we can see it here. And you can see that the continuity in between are just absolutely horrible. The reason that showing red is because of the layer here. I'll change it, and now everything is showing on the normal display color. So let's type in zebra again. You can see that there's no continuity in between at all whatsoever. And in order to fix that, we have to do some procedurals. So first, we have to refit the surfaces. I'll explain to you in a second. Let me explode that first. Select all of those surfaces, and I will come over here find a tool called refit surface to tolerance. I'll click it. And then right here, it says fitting tolerance is 0.1. And I will type in enter. I got it. So what this refit is doing is basically simplify the iso curves and control points on this surface, but at the same time to keep it as close as possible to the original shape. And that thing that's used to measure the closeness between the new surface and the old surface is called the fitting tolerance. And we set up as 0.1 here. That's great. Then let's go back to our instructions. Here it says rebuild surface 16988. Let's explain what is 16988. I'll select all of those surfaces and I'll type in rebuild. So in this rebuild here, it says point count. On the U direction, there is no such number. On the V direction is 3. Degree wise is 3 and 2. Okay. What are those means is that, for example, on this specific surface, it says on the U direction, there are 18 control points and there are 3 control points on the V direction. And the degree wise is 3 and 2. Okay, so those numbers in the parentheses are its original state. And the numbers right here, the number that you can change is a target number. You want to add more control points here on U direction, add more control points on the V direction, so on and so forth. And then you can change the degree. Okay, so we explained those earlier, that higher degree means that higher smoothness in between, and more control points, again, just gives you more controls, okay? I'll explain why we need more controls in just a second. So I'll hit cancel, and then I'll select all of them. I'll type in rebuild. The reason it didn't show a number here is means on those 3 surfaces, on the U direction, they don't have the same number, but on the other things, you have all the same numbers, so the parentheses show such thing. And please make sure that the U direction has 16 control points, V direction has 9, the degree wise, they have 8 and 8. There is no such magic formula for you to decide numbers over here. It's all based on your experiences. And for this specific case, please just use the number that I provided. And I'll hit OK. Give it a second. Okay, we got the new surfaces. And then I will go back to the instruction again. It says match surface. Okay, so this is a nice part. Before that, let's take a look. What is edge analysis? Okay, I'll select everything, join them all together, and then I will click all edges. Okay, so basically all edges means that, well, there's an edge here. No matter those surfaces are joined in together or not, I'm going to show it there. But the naked edges, it simply means that if this edge has no surfaces on both sides, for example, this edge has surfaces on this side and this side, it's okay. But this edge over here, it has surface on this side, but not surface on this side. So it will be considered as a naked edge. The naked edge helps us to determine if these points or the surfaces has been joined together or not, okay? So that's good that at least at this point, they are all joined together. So they at least have G0 continuity, but that's not what we want. So I explode everything and I will type in a thing called match surface. And then you can see that once I exploded everything, they have naked edges everywhere because they are not joined together. And then I will type in match surface. I will select untrimmed surface edge to change, okay? So right here, there's only this edge that's untrimmed, which is an edge on this surface. This surface, we have trimmed it already, so you will not select it. And then you select the curve or edge to match. On the second selection, okay, it doesn't matter this surface has been trimmed or not. So we will just select the edge on this surface, and then you will come to all kind of crazy settings you can select. You will make sure that you select the curvature, which means the continuity you want to maintain between this surface and this surface, okay? Make sure it's curvature and preserve other end. It doesn't really matter here because the other end has nothing attached. So I would just leave it curvature there. Match edge by closest points, which means that they are trying to find closest points in between here and here and here and trying to match it there. Basically what match surfaces is doing is that they will try to drag this edge, okay, drag this surface edge and try to match it with the other surface edge. And that is match surface. Okay, so sometimes because you don't have enough control points in between, they cannot drag it very well. That's why we have to change the number of control points and number of degrees, so on and so forth. And right here it says automatic, okay? If we click it to preserve isocurve direction, can you see the difference? The directionality of those isocurves has been changed. On this case, I would just choose preserve isocurve direction. This tool, usually we don't really touch the last two options because they are often give you a weird result. You really just want to choose the first or second in most of cases. Okay, I'll hit OK. And then let's take a look. Let me join those two surfaces together. The naked edge has disappeared. I'll type in zebra, and you can see that continuity in between is absolutely great. Okay, so that's what we want to do. I'll explode again, and I will do match surface again on this curve and this surface edge. And this arrow that's seen right here is telling you which surface you are selecting. I select this surface that I sweep to rail first, and then I'll select this tube the second. Okay, it just gave me an indicator. I'll select it and hit OK. Just keep all the previous setup, hit OK. And same as this edge and then this surface edge, hit OK. Okay, and then I will just repeat it on everywhere. So in this case, when we type in match surface, it allows me to choose this surface first, or this surface first, and make sure that you choose this surface first, because the first surface that you choose is the surface you want to drag. We already dragged those two surfaces to match with this one, so we don't want to mess up this surface at all. So again, just type in match surface. I'll select this surface, and now I'll select that edge, and now I'll hit OK. I'll repeat it on this one also, surface edge, and hit OK, and surface edge, hit OK. Okay, now I select everything and join them all together. Now I don't see any naked edges at all, which is amazing. And now I'll go to display mode, click off the surface isocurves and surface edges. Okay, and then I don't see any curves or edges around. That is exactly what we want. At the same time, I want to type in emap. And I've seen that this continuity in between is great. And let's lastly check the zebra line. And we might well see a lot of problems in between. Let's use the thinnest. So this is great. This is great. On the top is great. Let's use the medium first. All the continuity on this one is preserved. In between here are preserved. Well, so because we did it in the procedure that I just set up, everything in between looks great. Okay, so that's exactly what I want. Sometimes, for example, in between those two surfaces, and I'll type in zebra, sometimes you might well meet the problem that, or there are a little bit discontinuity in between those two surfaces. That's simply because we don't have enough control points among certain surface. For example, we don't have enough control points on this surface, on this direction. So what you want to do is you will insert knot here. For example, I will insert a bunch of knot, and then I will type in match surface and just do the procedure again, okay? But in our case, because our number has been well chosen, it's all good. So I will just go ahead and do that. And then the next thing I will do is I will explode everything, select all the surfaces, go to the front view and type in mirror, okay? I will just use this point or just use the origin as mirror and mirror to the other direction, okay? And then I'll select all the surfaces, hit join, and I'll type in zebra again, and you will see some problems. For example, vertical, and I will choose medium. You can see that there are some mismatch here. Let's choose thin, and you see that the strips lost its continuity. Thinner, definitely. And so that means that there are surfaces in between here. They need some special attention, okay? So we're gonna work on that the next. I will just click this off, and I will explode everything again. I'll type in match surface. I will select the first edge. Okay, the arrow goes up, and the second edge, arrow goes down. I'll just hit OK. Just keep this procedure. First edge as arrow goes up, second edge, hit OK, and then this and this again. Okay, now I'm going to join them all together, and let's take a look. Zebra, So the continuity in between those are great. In here, but you see that problem here, okay? You see that the continuity between this surface and this surface has problems now. Well, why is that? That's because when we dragging the bottom part, it caused a little bit discontinuity on the top of those control points. For example, those are the control points. When we drag the bottom one, sometimes the top ones has lost its continuity in between. So we might need to work on that, especially this case. You can see that this surface and this surface is definitely not that continuous in between because we drag this bottom curve a little bit. And how are we going to solve that? Well, as I mentioned earlier, we select this and we will insert a line of control points here and hit OK. Okay, and then I will type in match surface. I'll just match this one and this one again. Hit OK. And then let's join everything all together. And I'll type in zebra and let's take a look. You see that the mismatch has disappeared. When you zoom it in, it becomes smoother than before. Okay, so that's how we're going to do it. Okay, if this kind of thing happened to your case, you have to add some control points on that specific directions and then take care of it by matching the surface again. So I will just do one more time check. Okay, everything is great. So the next thing I will do is I will go to this surface again, explode everything. I will send this one to the trash. Then I'll select everything and join them together one more time. I'll go to the top view and I'll unhide the reference photo that we draw here earlier. And we see that here. We have this kind of curved edge right here. Right, we have this kind of curved edge. That's simply because this is a perspective rendering. It's not like a front view or top view of this device. So we don't have to worry about that. And let's take care of all the caps as our next goal. Okay, I'll just unhide the surface we just drew earlier. I'll come over here. Okay, I'll unhide this reference photo. I will type in duplicate border. I'll get those borders. So I'll select those curves. I'll type in planar surface, hit OK. This one also, hit OK. And this one, hit OK. I'll select all of the surfaces, join them all together. Again, in order to make sure that the edge condition is smoother and has this kind of fillet in between. Okay, I'll type in fitted edge. And then the next radius, I will do 2 here. Select this one, and type OK. Okay, and then let's take a look. Edge condition here is a little bit weird. That's because it doesn't have enough space here to fill it. Let's take a look, go to the top view and change it to shaded mode. Right here, this surface edge, it doesn't have enough space to fill it the edge. So what I will do is I will go back a few steps and then I will unhide the surface that we just sent to the trash layer. This one over here, okay? We need it. I will go to the top and type in scale 1D, and scale it from here to somewhere here. Give it a little bit space. And then right here, I will explode this surface, unselect this one, join them all together. And then, of course, I will send it back to the default layer. I'll select the surface, move it out to this edge, join them all together again. Okay, I will go to the top view and I will select fillet edges again. One more time, I'll select this edge, and 2 is good, hit OK, hit OK. Okay, now this edge condition is perfect. Okay, let's isolate it and take a look. See, it's perfect. There's no weird connections in between at all. Same as here. Okay, so we will do it right here also. I'll go to the fillet edges. Remember, you have to select this next radius first. I will change it to 1, hit enter, and then I will select the edge, hit enter, hit enter. Okay, I'll go to the top view and take a look. This looks much better than before. maybe 1 is not enough. We can change that too. You can decide to change the numbers based on your own ideas. That's not the point here. So let's isolate the curve and let's take a look. We need to draw a piece here, 2 pieces here, and then a sphere right here. So let's do that. In order to do so, I'll select the curve that we draw at the earliest point. Okay, make sure that they only have 8 control points. And the next thing I'm going to do is I'm going to move it along this direction. Okay, I will move it along this direction. I will scale it down a little bit. Okay, I'll go to the top view and I will hide this one. Again, select this, drag it. I'll move it inward a little bit. And again, type in planar surface. I will type in extrude surf, and I will extrude it. Make sure that I click both sides as off, so I can extrude it here. Again, use this as a reference. I will extrude it to this point, and I will type in fillet edges. I will choose 1 for this edge, hit OK, and I got it. Okay. The next thing I'm going to do, I will repeat what we did earlier here also. I will try to find the curve that I draw has the least amount of control points, and then I will hold Alt, drag it out, and then scale it down. Again, I will use this photo as reference. I'll go to the top view. Okay, now they have similar size, and then I will type in planar surface. I will extrude it inward a little bit. I'll type in fillet edge. I'll select this edge. 1 is good, hit OK. Okay, and then I will select this curve again one more time. I will drag it out, go to the top view, scale it down by holding Shift, and then I will type in planar surface, and then I will extrude it along this direction. This is great. I will type in fillet edge, select this edge, hit 1, everything's good, and just do it one more time. Okay, actually I can move this inward a little bit. I will just drag this in. Okay, I got this. And then last point is I will come over here and draw a point. Okay, I will make sure that I click the center. And I got the center over here, move it to here somewhere, go to the top view, make sure somewhere in between the sphere. And then I will type in sphere from this point. And then I'll go to the top view, try to hold the Shift, make sure that the iso curves are orthogonal. Okay, I can rotate it a little bit just to hide this one. It doesn't really matter. And then we are pretty much done for this surface. But let's go back and take a look of this reference photo one more time. We see the kind of made this split in between, and we have to do that also. And that is a little bit complicated. Okay, in order to do such thing, let's first hide all the surfaces that we just made. I will click filter and click off the curves and make sure that surfaces or poly surfaces has been selected. I'll select all of them, make a group and hide them. Okay, and I'll click off the filter. I'll select all the curves and points that I drew earlier, send them to trash. I will hide the trash layer. Now let's focus on this edge condition. So first, I will draw a line right here. And then I'll click on the trash layer. I will click this line, I'll explode it, and then I'll select it and then drag it. Okay, I'll just copy this and send this to the default layer, hide this trash one more time, select this, okay, and then move it somewhere here. Again, I will lock this image. I will unhide everything else. Got this one. I will explode everything and ungroup all of them. I'll select the surface, go to the top view, change it to wireframe mode, and then I will type in extract iso curve. Okay, so I need this curve right here. Okay, we can use this as reference. Hit OK. Okay, we got this curve. I will explain to you why we are doing those in a second. And then I will select this curve, move it here, select this curve also, and select this curve. Let's isolate all of them, and we are almost done. Okay, I'll select all of them, type in set pt. What this function is doing is that we click the Z one, and then if we choose this point as our reference, it will change the control points of all those curves we want to change and make them have the same Z value as our reference point. And then I will go to the top view. I will draw a line here from here to here and type in fillet. Just 11 is good. I will hit OK. I will select all the curves, join them all together, come over here and drag it down a little bit, and then I'll extrude it up. Okay, I will get this surface. Let me join them all together. And then I will come over here, select Boolean split, select the surface of polysurfaces to split, hit enter, and select the cutting objects, hit enter. Okay, and then again, I will send this to the trash layer. Well, now let's move it here. Let's just move it to 111 units. Okay, and the reason that I move this curve out a little bit by using the ISO curve is because I will fillet those edge if I have to deal the edge condition on this surface, and the fillet edge will not work well between the surfaces like this one and this one. Okay, the edge condition here will be complicated. So I offset it a little bit by using the extract ISO curve, and to avoid that kind of situation, again, I will join them all together, and I will type in fillet edge. I will change next radius to 0.3, let's say, and I'll select all the edges by click them, hit enter, hit enter. Okay, you can see that this edge has been filleted and it looks great. All the connections in between are great. Okay, so do the same thing by hit space one more time, select all the edges, 0.3 sounds reasonable, change them, and got it. And then I will type in minus 111. It doesn't have to be 111, just a number you can remember, or you can just simply hide them. And now we got it. This actually looks great. Okay, I'll go to the display mode and hide the ISO curves and the surface edge. Okay, and that is the process of making this model. So that's it. That's all we're going to talk about today. And please follow these details of this modeling process. It's very important to learn how to blend those three tubes together, right? One tube here, one tube here, and the other tube was here. And then let's go over the process again. First, you blend the curves to set up the sweep two rails, and then you refit those surfaces, make them simpler, have less control points, and then you will rebuild the surface by using 16 control points, 9 control points, and 8 degree. And then you will match the surface edges, right? You will drag those edges around and make sure that the continuity in between surfaces are great. And last thing is you will add ISO curves at local that is necessary when some part being dragged and the leftover has been problematic. You have to add more control points over there by using this tool called insert knot. Okay, so again, this process looks very tedious, but that's what's necessary for us to do in order to keep this perfect continuity for our model projects. Thank you so much, and I'm looking forward to seeing you in our next tutorial.